Alright, so we are going to talk today about Docker running on macOS. So a little bit about me. You guys don't have to worry about trying to read this big block of text. This is more for the PDF side of things once everything's done. But I'm the VP of Engineering for FileWave. You've probably seen our booth out there and our logo up around. We're sponsoring the conference. But this is not a FileWave talk. This is just a talk strictly about Docker. I will talk a little bit about what we're doing with some Docker stuff toward the end, but I became a FileWave customer in 2006 when I was working for a K-12 school district that was managing almost about 8,000 machines. About 7,500 of those were Macs. Before that, I worked in higher ed. I've worked for enterprise. And I've been playing around with Macs for a really long time. So I actually just found before I flew here, I have some old PowerPC 6100 pizza box Macs in my attic that I bought from a university a long time ago. So if anyone has any interest in those, I've got like 8 left. So I don't know what you'd do with a 6100 at this time, but anyway. So I've been messing around with Macs for a long time. And doing support. So now, obviously been with FileWave since we went through all of the renaissance now with iOS and VPP and DEP and all that fun stuff as well. So I now manage the engineering team at FileWave, so all of our field engineers, professional services, etc. support and the QA team. So basically anything that involves technical skills and isn't development falls to me. So and my teams. So I'm going to talk a little bit about what we're going to talk about today. So what exactly is Docker? A lot of people have heard about it. It obviously gets a lot of traction. It's almost become its own buzzword. And people just say like, oh, you can just, Docker, right? And everybody gets all excited. Why would you want to use it? Why leverage Docker? When does it fit? When is it the right fit for you guys? And when I'm talking about leveraging it, how do I deal with it versus other tool sets that I might have? So maybe I have access to VMs, maybe I have access to cloud infrastructure where I use tools that I just pick apps and things load and they're magically available and I don't know what's happening on the back end and that's okay. And so we'll talk a little bit about that as well. We're going to do a little bit of terminal work today, so I'm going to assume you have some familiarity with the terminal, although the Docker commands are pretty basic. We're going to look at some sample containers. We're going to dissect a container a little bit and talk about how containers are actually created from what are called Docker files or Docker images. And then we're going to get some containers running on my Mac right here today and take a look at what we can do with them. And then we'll also do I'll talk about some resources that you guys can use to move forward if you want to keep going. And obviously we'll do some Q&A. So big warning, big upfront, I am not a Docker expert. This is not a session where I'm going to show off all my elite Docker skills. My elite Docker skills do not exist. I am a functional Docker user. And so that's what we're going to talk about today. There are plenty of Docker resources out there, and the community that has come together around the tool set is really, really great. I just got back from my second DockerCon a few weeks ago, and for scheduling reasons, I couldn't go to the one here in the US, and we went to the one out in Europe as well instead. So, and both experiences there have been amazing. I come back with a big really great knowledge set when you get back, and the people you meet there are just fantastic. It's just a great community. So if I'm not an expert, what is my goal? My goal is to get you interested in learning more about Docker and seeing how easy it is for you to use and how flexible it can be for you. So I stole this little picture from The Simpsons, which, cracks me up. So what is a Docker container? All right, so enough of that stuff. What are we actually talking about here? So if you go to docker.com, Docker has now become focused on the enterprise side of Docker, right? So if you go to docker.com, the company Docker is now focused on the enterprise side. You'll read a lot in there about microservices, and you'll read about legacy app updating and all of these other things. And they absolutely have a path that's set for that. That is part of the tool set that they want to leverage. That's not really a lot of what we're going to talk about today, because when you're sitting as a person on the IT side of things, or when you're a developer who's needing to set up environments or set up repeatable test machines that you're accessing or you're utilizing to run tests, the microservices piece and all that other stuff doesn't really matter. There's a whole side of Docker that is tagged toward DevOps, and so we're not going to be dealing with so much with that today. But anyway, let's break down what they're talking about here. So containers contain all of the major components that are required for applications to run. So inside of a container, you're going to have all of the essential pieces for that particular application. So if we're talking about something like Apache, right, you're going to have all the libs that are required, you're going to have the actual executable files, you're going to have any of those components that would be installed to support that application. But what you're not going to contain, or what they're not going to add in there, is all the extra overhead required for the kernel. They share the resources of the host machine that they are running on. And so what that means is that they're actually leveraging some of the kernel extensions, obviously all the hardware, CPU, RAM, hard drive, etc. And they're leveraging that when they're running as they need them from the system themselves. But they are completely contained inside the container that is created when they're launched. So Docker runs on all major operating systems, Mac, Windows, and Linux. And the cool thing is, containers that are created are portable from one system to another. So your dev box might be a Mac, but when you push to production, you can actually push the container to maybe a Windows server that's running with Docker enabled, and that container will run on Windows just the same with absolutely no changes. The other cool thing that we're starting to see in the marketplace now is if you have like a Synology box, or I think ReadyNAS is doing it as well, that a lot of these tools are also allowing containers to run so that you can run file sharing services and other things like that that are made publicly available. You can pull them down and execute them and run them as well. And so containers can reliably run one service, so you can think like a TFTP server, right? Or they can run multiple services as needed. And it's easy to script containers, and you'll start to see why once we start working through them a little bit. It's easier to script with containers, take action, execute commands inside containers when you launch them. All of that is scriptable inside, and then if you start customizing the containers yourself, you can actually continue that workflow on your own. So why would I want to use it? Well, if you're already spinning up specific application VMs, there's a likelihood that you are, what I'm saying, are abusing snapshots. And what I mean by this is when you actually go in, so let's say you're using Fusion, or you're using Parallels, and you go in and you actually see how much space your VM is using, and it's using like 40 gigs. You're like, why is my little Ubuntu installation using 40 gigs? And it's because you've made 6 snapshots, like as you've updated things and going along. And you're doing that because when you launch that and you want to use it to test something, you are launching that VM, taking a snapshot of its current state, where you already have a snapshot of its current state, then you're making your test, doing your change or whatever, and then you want to be able to get back to that starting point again so that it's clean and ready to go. So one of the things that containers allow you to do is create a clean environment every time you spin up the container so that you don't have to do that. Maybe you've tried some automation tools already. So if you're in a dev environment, it's very possible that you said, like, every time I need to do this, I need these tools installed, I need these scripts to run, I need all of these things to execute. And so you're using tools like Ansible or Vagrant or Puppet to try and make that happen, and it's starting to become frustrating, or maybe there's a steep learning curve with some of these tools, or maybe, I know Vagrant's fixed this, so I'm not picking on them, but for years, Vagrant would only work on certain VM hosts. It wouldn't work on other ones, so you can only use it if you were going to leverage the VM in a certain location or a certain host type. So maybe you've run into those kind of problems as well, and you want to try something different. Or you need certain services and tools only periodically. Keeping a VM around that has all of that stuff already installed and ready to rock is slow and maybe takes up too much space, right? And so you have to keep everything that's there. You have to have the entire installation there all the time. You've got maybe a thin or thick provision hard drive that's just taking up space on your machine for no reason, or taking up space on your server for no reason most of the time when you need it. And we're going to talk a little bit more as we move forward. You'll start to see how, as we build the containers, we can pull them down as we need them. Right? So speaking of VMs, I've heard all Docker people hate VMs. Do you hate VMs? Of course the answer is no, right? So when any new technology comes along and it starts to become popular and you start to hear about it more and more and it starts to become a buzzword, you get a lot of people that will become naysayers of said technology, and they will leverage things about that as well, right? And so having people that are saying, like you can't have either or, it must be either or you can't have both, or whatever is ridiculous, right? Not all Docker people hate VMs. We love VMs. We use them all the time, and I still use them. So will Docker replace all of my VMs? And the answer to that, of course, is also no, right? It's possible, if you're not really using VMs really heavily and you're just using them for some of those examples I gave earlier, that you might find yourself in a situation where your Docker instances do replace what you were doing with those VMs. And that's totally fine. That's absolutely fine if that's the case, and that's great. But probably not. There's probably going to be some reasons why you need to spin them up, and we'll talk about some of those as well. And that's really not the goal here, right? My goal is not to replace your VMs, right? Or not to come in and kind of change the way that you're doing things. My goal is really to provide this for you as an option, and then hopefully you can find a good use for it as well. All right, so let's take a look. So the first thing, if you want to follow along, you can. It will require you to install Docker on your machine, but you can go right now to docker.com/docker-mac. and pull down the Docker installer and execute it on your machine. And what you will get is the actual Docker. It will look like a single installation, but what it's really doing is it's installing all of the components that are required. So the way that Docker works is there's a Docker engine that's running on your machine, and then there's a Docker API that is actually used to call that engine and make changes. So things are done outside the engine and then fed to the engine inside. So once it's installed, you can launch the Docker app that you've installed. And you'll see it will take a few minutes for Docker to fire up. It takes a few minutes for the engine to fire up. But once you see in your toolbar, you'll see a little whale icon with a bunch of little containers on them. And once he's done moving those containers around, your Docker engine's launched and it's ready to rock. So once you've done that, you open the terminal. You can type simply docker run hello-world. Okay? And what happens when you type that is you will actually get a description of what just happened on your machine. So you'll see your terminal spew some output, and you'll actually get a description of what just happened. And that's the great thing. And so as I was talking earlier about the community here, you start to get an idea of how this community is designed and how they want you to be able to use the product. So you should see something like this. Hello from Docker. This message shows that your installation appears to be working correctly. And then underneath that, it says, here's what happened to generate this message inside your terminal. It's easy to think that, I just ran a command and then it spewed out some stuff that was already previously scripted, but that's not exactly what happened. What happened is the Docker client contacted the Docker daemon. The Docker daemon pulled the Hello World image from the Docker hub. The Docker daemon created a new container from that image, which runs the executable and produces the output that you're currently reading. So basically what happened is we have a situation where we've called, when we ran that command, we've asked Docker to go out, pull a Docker image down. It's executed that Docker image and created a container. That container is now running that code. And the instruction for that container was to basically spew the output that you are now reading into your terminal. Okay, so you run your first container at this point, and that was easy, right? And yes, that's exactly right. And so I was going to talk about hubs here in a minute, but we can bring it up and talk a little bit about it now. So one of the really cool things about Docker is that they allow you guys to pull from any public repository, and they call it Docker Hub. And you can pull those down and add them just by pathing to the path for that particular image. And I'll show you that here in a second. But you can also create your own, and you can store your images there. So you can pull down someone's Docker image, you can tweak it the way that you want, and you can save that and upload it to your repo. So if you need to make a slight change, or you need to tweak a way that somebody else did something, they have 90% of what you wanted, and you need to add that extra 10%, you can do that and then pull that down as well. And that also makes getting into Docker really easy because it's been around for a few years now, and so it's likely that someone has built a tool that you would like to try to use. And so a lot of the Docker image stuff, when we start looking at the Docker files, you'll see that. Most of those are also stored in GitHub as well. So you can actually pull someone's Docker image file down and tweak it directly, and you don't have to pull their image. But we'll talk a little bit more about that here in a second. Oh, sorry, I skipped a step. So the Docker, it streamed the output, put it in your terminal, and that's what you were seeing there. So what's in an image? So I keep using the term image, and I keep using the term container, and it is true, a lot of times when you go online, you try to find someone's definition of Docker, they'll use the two words interchangeably, or maybe feels like they're using the two words interchangeably. They are slightly different. One of the reasons that it's so quick to pull, when you do something like Docker Hello World, and you pull that down from a Docker hub somewhere, is because there's actually not a lot in there except instructions. And that is what is in the image, okay? This is the instructions on how to build this container on your machine and get it running. And if there's any additional steps, what those additional steps would look like. So the contents of your container are set in that image with a Docker file. So what do you want this container to look like once it's launched? The Docker file is written in YAML, but if you're not big on YAML, that's fine. Once you see the format for the Docker container, it's pretty easy. And the biggest thing is, utilizing some of those Docker resources to find out exactly what command options you have. Now, when I show you some of the ones today, we're going to look at a few of the basic commands that you would need to get something running with an actual service that you can talk to. And you'll see those that your containers can use to run. So one of my favorite tricks is just to pull a base CentOS image. And I did not do that, but we were going to do that anyway, so I guess that's okay for now. Can you guys, there's no way. Is that better? Let's try that. All right. I'll cheat again here. Okay. All right, so what we can do here is we can run that. And so what I'm actually going to run is a modified version of that just so we can see something here in a minute. But basically what I'm saying is Docker run, I'm feeding in some arguments, and I'm pulling I'm just asking for CentOS. So what that's going to do is go out and find a Docker image for me of the latest version of CentOS and pull that down and run it. Now remember, I'm not downloading CentOS in that sense, right? I'm just downloading that and executing it out. And so just to give you an idea of what we're looking at here, I'm asking it to run this in the terminal. I'm asking it to pass port 8080 to 80 inside the container once it's launched. And I'm asking it to go ahead and execute bin bash for me so I have something to work with. So I'm going to go ahead and hit return. Now, in the last 24 hours, I have already pulled down this image. And so this is going to be almost instant because I have the latest version of CentOS Docker container sitting on my machine, so it just fired it up right there. So what I have right here running is an actual container running CentOS in it, and so I can do like, let's see. Well, normally I can. Oh, maybe not. All right. So I've got it. It's a CentOS build that's running inside my container, and I can treat it just like I would a CentOS VM that I've SSH'd into, right? So if I want to add software to this, I can. We'll do a yum update, because this is basically a CentOS minimal that's running, so nothing's been previously downloaded or anything like that. It's leveraging the network connection that I'm currently using on my machine, so similar to if you had a VM running, how you've added, got everything set up. We'll run some updates here. And and then we can actually go in and add software to this as well, right? Just like you would with a standard CentOS installation, right? I can go in and do yum install HTTPD, right? And so we're pulling down a CentOS version of Apache and getting that set up here inside our container. So if you have a need to basically spin up Ubuntu or CentOS or some other Linux distro, Alpine, whatever it might be, you can go in and actually execute that container, and you're in it just like this, right? So I'm not doing anything extra in that regard. And so now we've got this set up, and we're running Apache. I think we can just do okay. And so because I've obviously set up, I have no fully qualified domain name or anything like that. I get a standard running Apache error. And remember earlier, I launched this container and I passed port 8080 over to 80 inside the container. So we'll go to 127.0.180.80, and there's our running Apache server inside our container. So I can do that, right? That's pretty cool. And I can set up this container, and it only took me a few seconds. And the best part is, it gets even better. So I don't even have to do all of that. But this is probably the thing I do the most, because sometimes I just need to spin something up and check something real quick. Or I may not use CentOS, right? I may use Ubuntu. I need to check something, or I need to run a script, or I need to see how an executable behaves. And I don't want to spin up a VM or try to make sure I'm keeping the latest version of Ubuntu in a VM somewhere. So this is really nice because it always pulls latest, and if there's update, then it'll pull that version of the update. So instead what we could do is we could build a Docker container that is built directly for Apache, right? So why go through all those steps I just went through when I can feed all of that information into my image, so that when I pull it down, it automatically installs Apache, it automatically launches it, it automatically sets the writes that need to be set, and it automatically exposes the port, right? So let's go line by line real quick and just take a look at what we're doing here. So the first thing in is going to be from, and then we're saying what Docker image we want to start with, right? And the cool thing about this is I could just start listing Apache images here that someone else has already built, right? Or I could add in, if I wanted to add in PHP, I could also do from and then add a PHP Docker image that I want to pull, and I could add that in as well and combine them together. Right, but in this one, we're just starting with Ubuntu, and we're going to actually manually run the installer for Apache. So the maintainer is usually who you want to talk to if something goes wrong. Usually people will put either the address for their Git repo, or they'll put their email address in, or they might just put their name. But most people will put in some pretty basic information about themselves. And then we have run, which allows us to run this command while we're setting up the container. So as part of that, we're going ahead and doing apt-get update, because this is Ubuntu based, right? So we're doing apt-get, and we're also installing Apache 2. And then of course we have environment variables that we're executing then immediately after that to set writes. And then after that, we're telling it that when we launch this, one of the arguments we want to launch with is that we want to expose port 80 on this container, right? You saw when I launched mine, I actually launched it and I did 8080 to 80. So you can set that as well in here. And then execute with these commands. So the commands I ran where I was actually telling it to launch bin bash and run inside my terminal, I could put those in here as well, right? So I could bake all this in. They're just saying go ahead and launch Apache 2 and run with that command, and that way it's launched and running. Okay? So what if we want to build like a custom LAMP stack, right? We need our own version. We want to use a specific database, or we want to use a specific version of PHP, because God knows you have to. And that's my anti-PHP joke. I'm sorry if there's PHP people here. So if you have a certain version of PHP that you have to run, or whatever it is that you need to do, you can pick, right? So you can set that up. But you need to choose wisely, because there are a couple ways that when you're running multiple services, that you need to set these up inside your container. So you need to go back to what we talked about at the beginning and think about why you're doing this, right? Am I doing this because I need something easy that I can spin up really quickly, and I need it all put together, and I'm probably always going to do it the exact same way? Because if that's the case, then we do it all in one container. Okay? We combine all of those services into one container, just like you would if you were building a VM and you were going to install a LAMP stack in your VM. So you can add all of your LAMP components inside. You can configure them all in one Docker file, right? And this is good for quick or simple setups that you're going to use often. And you can see what happens is that the container actually runs. And just like the one I used here, it creates virtual Ethernet connection. And I was able to connect through it, and it passes through anything sent. If I have ports open or whatever needs to happen inside there, I can do that. So you can also, inside your image, and we didn't really talk about this, but if you have apps that you want to execute, so if you want to use Python or something like that and load those apps in, or if you're into JavaScript and you want to do some stuff with Node, you can pull that stuff down. You can either pull from GitHub as part of the creation of your image file and pull the latest version of your installation, or you can actually provide the files as part of the image in there with the Docker file and reference them. Or you can set this up as independent services, right? So I can have my web and PHP in one container, right? And I can have my DB in another container. And if I want to upgrade to a new version of PHP, all I have to do is bring down my web PHP container, upgrade it to a new one, bring it back up, and leave my DBs up and running still so that it's available, right? So this is really good if you're in an environment where you're going to start moving things into production. And you guys know just as well as anybody that saying production, a lot of times people just assume that we're putting this in front of customer facing. Production might be internal production, right? So it might just be that this is a little server that we run and it pulls some data from the CRM, and I just need my internal guys to be able to reference it really quickly, because it's just, instead of running the same report out of the CRM every day, right? It might be something just like that, right? I just want a web page for them to go to and see this dump of data. Right, so it's in production, it's being used daily by users, but that doesn't necessarily mean it's mission critical. So you can do this, right? You can set this up, you can set up these containers, and you can spin this up on a server somewhere else once you proof of concepted it on your machine, right? But this is good for anything where you require high availability or anything along those lines as well. And again, here you can see what the Docker engine does is it goes ahead and sets up everything for the network and everything for you there so that you can choose how those two things connect. And of course, the cool thing is the containers can see each other via the network bridges that are created. Right? So here's a sample of a LAMP stack where we are actually doing it very similar to the way we did the Apache stack. Now, I chose to do it this way rather than just do from Ubuntu latest, from Apache latest, from PHP latest, from whatever, right? So that we could actually see how we get things created. And again, we're just going to run apt-get update. We're going to turn off the interactive options. That's optional, that's up to you. If you're a big Debian guy, you can decide if you want to allow that or not. We're going to pull Apache, we're going to pull MySQL Server, PHP 7, a couple of extra pieces. And then in this case, remember I talked about if you have an application inside your Docker, inside your image with your Docker file, you can also put a script in there. So if you just have a script that you want to run, that in this case is going to set some writes, probably set up a DB, do a couple of other things, you can drop that in there and you can tell the container to execute that when it's being created, so it executes it as part of the build process. And then, of course, we're going to run that start script that we're pulling in. And then we are going to run this with a command that it's going to execute the start script when it runs. All right, so I want to talk a little bit about how we use Docker, at FileWave. So outside of the fact that I already told you, kind of, I use it as a tool set that allows me to spin things up quickly or make things accessible quickly, or give myself a access to a Linux distro when I would have had to set up a VM and had gone through a live CD installation and all those other things. We also have started using it for some of our tool sets. So internally, obviously, our product has a key server that's created. One of the things that we did initially, John Clayton as our CTO and I, although mostly John, Dockerized the key server that we use. And we did it as an experiment, and we actually did it using this methodology here, where we actually separated out the DB and the front-end interface are completely now separated out from each other and running independently of each other, so we can upgrade one without affecting the other necessarily. And so this allows us to keep these up and running. And our key server is able to be operational inside this environment, running as a set of containers. And if we wanted to expand out availability or we wanted to take advantage of some of the other Docker features, we could. Once you guys start going down the path of Docker and you start going down that DevOps side of like making things available, there are a bunch of other features, including Swarm and things like that, that you can do as well. And the Docker team has started adding some of that stuff to the clients for desktop devices. And so you'll be able to start playing with that stuff really soon. So here's a few resources for you guys. The Docker products resources piece is there, and that has video tutorials, PDFs, everything that you could need to move forward with that. The hub is there, the Docker Hub container for Mac admins exists as well. So if you guys are looking for some open source tool sets, there's a couple of things that are related in there. There is they've already created one that does like netboot and a couple of other things. It looks like most of these were created a few years ago, but the cool thing about any Docker file is that if you've created it to pull latest every time it builds, a lot of times you don't have to change the Docker files once you've created them. If they're pulling data from GitHub or anything like that, they're usually solid, and it's just the actual binaries that are getting pulled down that are going to change. And then a couple of people that not only do I follow on Twitter, but I think are really amazing resources for Docker stuff, and you'll find presentations from both of them from DockerCons and other conferences, Kubernetes conferences and things like that. Is Phil Estes, and he works for IBM and does a lot with the containerization there, but he makes a lot of his like R&D stuff and a lot of things he makes available for Docker. He's a Docker captain. They have a lot of leaders inside the community, and he is one of them. And then Jesse Frizzell is a developer that has worked for Docker and Google, and now works for Microsoft as well. She jokingly calls herself the Kaiser Soze of containers. She has a great talk. If you want to go see it on YouTube, it's from a few years ago. But she's running Linux on the desktop, and she actually Dockerizes almost every single app that she is using. So you're talking Spotify, Skype, OpenOffice, all of these things, and she has containers for all of them. And the cool thing about this is, right, so when you're talking about things like that, this Apache container that I'm running, right, if we go to, hang on, let me go ahead and make this guy big also. All right, if we go over here and I type docker ps, no, that's not going to work. I can see what containers I'm running, and you can see I'm still running my, my CentOS container here, and it's given it a random name. And there's a couple reasons for that as you move forward. When you start running commands and containers, you can reference them via name, you can reference network stuff via name. as well, but or you can identify it by the ID number that's provided over there as well. But you can see that my container is running, right? My Apache server is still running on here, so let's do a refresh. Yep, so he's still there and happy. And so if I have my other terminal window here and I just type exit, okay, we've exited my container. But because the container was running, when I launched it, I told it to run and provide me with a terminal. When I'm done with the terminal, I'm done with the container. And so the whole thing was ephemeral. And now that container is no longer running, no longer taking up space, no longer taking up resources. It's completely done. I'm done with it, right? Now, I've lost everything that I've done, right? So, you have to be aware of that. But there are ways to mount volumes and things like that inside your container so that you can feed them data. In fact, one of the really cool things that you can do when you do that is you can build in your Docker, inside your Docker file, a mount location, let's say for your website container that you've built. And so if you built that website container, you always want it to pull from a www folder on your desktop when you launch it, and whatever content's in there, that's what it's going to load. Right? You can do that, and it will launch that every time. And when you close the container, of course, the directory that's on your desktop is still sitting there, and it's ready to go next time you launch the container, and it's going to pull that data. So there's really cool stuff that you can do there. So I hope I gave you guys a good taste of kind of what you can do. If you're really interested, if you're part of the monkey world, or you're part of I am determined to run this Mac-only service on Linux world, you can, that Mac Admins Docker Hub has a ton of great stuff in it, and even if some of the stuff has been neglected, just reading through the Docker files and seeing those components that they're using in there is going to help quite a bit. So really cool stuff that you can do there. So any questions or anything like that?
We've definitely got some time if you've got questions. Let me bring the mic.
A little bit of Docker before I ever did anything with it, but I'm a little confused about what it is as far as, like, it's not a VM, right? So,
right.
So what is it? What is the context in which the code is running?
Yeah, no, that's a great question. That's a common question. I was actually joking with somebody earlier today about this exact same thing. I said the funny thing about Docker is every time someone tries to explain what it is, someone else will actually in like 5 minutes. And because everybody has a hard time explaining exactly how it works. There's a great diagram. I say great diagram. I didn't grab it. Darcy's one of my engineers. She's sitting back here in the back. But she's going to yell at me because she wanted me to use it because it has a great cat in it. But she's like, how can you not use this? There's a great cat. And I didn't pull it in there because I thought it would take me too much time to walk through it. But the point of it is what it uses and how it leverages the resources on the machine. So basically what it does is it's using the Docker engine to create these containers based off these recipes, right? These Docker files that you've created. But it's only what's running inside the container are only the things that you've specified to run inside that container. And they're leveraging the resources that are normally provided by your system to run applications. So an easy way to think about it is that if I give you a binary for an application, I'm not also giving you an entire installation, right, of macOS. I'm just giving you the binary, and I'm trusting that all of those things exist on your system. And so you can kind of think of it that way, is that instead of spinning up another machine, that is another VM, that is going to recreate the wheel, right, and recreate all of those pieces that are running as part of that operating system, I'm just going to scrap all that stuff that's different, or that's the same, sorry, and just keep the stuff that's different and leverage what's on the machine to make those calls. There's a whole other layer of how the APIs talk and how things are kept safe and ephemeral inside the container, but that's kind of the basic gist of it, if that helped. Maybe it didn't. I'm seeing your face, so I'm worried. And we can continue that. I mean, we can talk about that a little bit more as well, but yeah.
Anybody else?
Did I just make it worse for everyone else?
I have a question. Are there any apps that don't run well in Docker? And the reason I ask the question is that we've become aware that GFI is now, since they purchased Curio, has moved Curio servers to Docker containers, and it is a crash magnet.
Yeah. So I would argue that anything that is based in Linux, okay, will run really well in Docker. Docker has recently made Windows apps available to be migrated and run in Docker containers as well. So using the same kind of technology on a Windows server, you can execute Windows apps. And this has been really big push to move some old legacy apps into containers so that you can do high availability and scalability and other things like that as well. I would say that there are certain applications that if we do it, if you go back to my deck here, there's a temptation, right, to build all of your Docker applications this way. Because it's easy and it's fast and you can proof of concept things really easily. The problem is that when you start running applications using this method in areas where they're going to come under load and they're going to be exposed to customers who are going to break things, or whatever it happens to do, is that everything is now trapped in there just like it would be in an installation that you've created in a virtual machine. And so if you have a problem like that, it makes it just as difficult to diagnose what's going on inside. And it also creates a situation where you cannot spread the load anymore of those services out. And so if you can create like smaller containers, right? So if you can create independent services, and this is where that talk about microservices, I'm trying to do this without any buzzwords and you guys have trapped me. So if you hear all the talk about microservices and things being brought down to the smallest possible set of components that are running, the idea is exactly this, right? If I can cut everything down to just the pieces that I need, I know exactly where there's a problem, when there's a problem, and why there's a problem, and I can fix that. Whether it's fixing code, whether it's applying more resources, I just need more hardware, I can move the container to a machine that has more resources, right? Or maybe it's just the fact that I was trying to run that service in an environment that wasn't good for that service, right? Network couldn't keep up or whatever it happens to be, so I can push that part of the service into the cloud. And I can keep the rest of it, where I want to keep it. So there's a number of different ways to kind of keep that there. And I think it is going to be growing pains for a lot of companies that are moving things into production with Docker. We actually just took our classroom management tool, Engage, so you guys see a big pop-up out there by our booth for Engage. So it's a standalone server. It requires FileWave, but it's its own server that runs. And historically, we've given it out as a VM appliance because that was the easiest way for us to deploy it and distribute it. So we've recently Dockerized it, and then the next step is to seriously load it down because it is not just a web server, right? It's doing a lot of API calls back and forth. It's maintaining and tracking a lot of data that comes from student information systems and doing a bunch of other things that, it's very difficult for us to load test that stuff outside of a production environment. So that's kind of our next step. And yes, there are situations where as things move into production, there's definitely going to have to be a little bit of a learning curve. For things like that.
Anybody else? Cool. Thank you, Dave.
All right, awesome.
Awesome session.
So I will redefine Docker here.